Let's talk about classification model validation. You may have built a classification model or multiple classification models. Now, you would like to test and compare which model is performing better and is more accurate. In this video, we will talk about different methods and metrics that can be used to compare the model performance. For training a model, training set is used. That is, a subset of the data set that the classifier can use to learn the underlying patterns. For testing, it is best to use a test set. That is, a subset of the data set that the classifier has not seen. If training set is used for validation, it can lead to over-optimistic results. The following terms are crucial in calculating the validation matrix. True positive, the positive labels that were correctly classified. True negative, the negative labels that were correctly classified. False positive, the negative labels classified as positives. False negatives, the positive labels classified as negatives. These are represented in the form of a confusion matrix. Confusion matrix is a useful tool to analyze the classifier performance. For a good classifier, most of the results would be represented in the true positive and true negative sets. Let's talk about the validation matrix. Accuracy. This is the percent of test set records that are correctly classified by the classifier. It is calculated as the sum of true positives and true negatives divided by the total number of records in the dataset. Using just accuracy to determine the performance of the model is not the best approach, as it is dependent on the class imbalance. A higher number of positives or negatives will bias the results on the high frequency class that can result in a high accuracy of the model. To address this problem, other measures are used. Precision. It's the percent of data points that are classified as positives that are actually positives. It can also be understood as how many of the predicted items are relevant. It is also known as measure of exactness. This is calculated as true positives divided by the sum of true positives and false positives. Recall. The percent of data points that are correctly classified. It can also be understood as how many relevant items are selected. This is also known as true positive rate or sensitivity. It is calculated as true positive divided by the sum of true positive and false negatives. There is an inverse relationship between precision and recall, and it is possible to increase one at the cost of reducing the other, thereby impacting the overall model performance. An alternate way is to use precision and recall together. F1 score. It provides the ability to use both precision and recall together for evaluating model performance. This is a blend of precision and recall and is calculated as the harmonic mean of both the matrix. It gives equal weight to both precision and recall. It is calculated as 2 multiplied by the product of precision and recall divided by the sum of precision and recall. In this case, any abnormality in the values will result in a lower F1 score, which will indicate the issue with the model. A balanced model will have a higher value of the F1 score. Specificity. It is the percent of predicted negative values that are actually negative. It is calculated as true negatives divided by the sum of true negatives and false positives. Receiver operating characteristics, also known as ROC. It is a graphical plot that illustrates the diagnostic ability of a binary classifier as the threshold is varied. The ROC curve is created by plotting the true positive rate against the false positive rate at various classification thresholds. A classifier that is more accurate will have a higher true positive rate and a lower false positive rate, resulting in a ROC curve that is closer to the top left corner of the plot. The area under the ROC curve is a measure of classifier's overall accuracy. A classifier that is more accurate will have a higher AUC, with a perfect classifier having an AUC of 1. ROC curves provide a robust mechanism for evaluating the classifier performance, as they are not sensitive to class imbalances.